Let's use the same setup that we had before. We have two random variables x and y. The mean of x is the mu of x, the mu of y is mu of y, the variance is x is sigma square x, the variance of y is sigma square y. And now let's be general and assume that they're correlated with a covariance that is sigma x y. So in this case now, instead of the sum, we're going to look at the difference. So what is the variance of the difference? We're going to do exactly what we did before. So this is going to be the expectation of the variable itself minus its expectation squared. So what is equal to is the expectation of x minus y minus e of x. Now, with the careful minus and minus becomes plus e of y, everything squared. Now I'm going to collect, so this is x minus mu of x minus y plus mu of y squared. Now I'm going to collect in a way that makes sense, again in the form of x minus mu of x minus y minus mu of y squared. Oops. This is supposed to be square outside, that's why you need to be careful. So, and now I'm just going to do the square piece by piece. So I have expectation x minus mu of x squared. Now this is plus y minus mu of y squared minus 2 times x minus mu of x and y minus mu of y. You can see that now we can use the fact that expectation is a linear operator. So this is e of x minus mu of x squared plus e of y minus v of y squared minus 2 times the expectation of x minus mu of x, y minus mu of y. But what is this equal to is the variance of x plus the variance of y minus 2 times the covariance of x and y. So this is similar to what we had before with one big difference, that now we have a minus there. So what happens if x and y are independent? So we have, now we proved that the variance of x minus y is sigma square x plus sigma square y minus 2 sigma x and y. If x and y are independent, then the covariance is 0. So what is, we get that the variance of x minus y is the sum of sigma square plus sigma square y. So here you have to be careful, because even though we had a sum up here and the variance of the sum is the sum of the variances, the variance of the difference is still gonna be the sum of the variances. And you can look at the movie that I posted in your module from the Khan Academy to see an intuition of why that's the case.